That's small break. Okay, now following guys. So here again we discussed about a application layer, presentation layer, and session layer. So in session layer, I am not completely told what is session layer. It is I just told about when you are sending a message, like you are sending a request. While you are sending, you create a session ID. When receiving, one is completely received and it will give reply, right? It means once complete transaction completed, once a transaction is completed, then session ID will be terminated automatically. Till the time it will maintain the session ID. And I given one point here. It is don't press back or refresh the page while you are transmitting data, right? While you are paying money. Yet okay, at paying means Amazon, Flipkart. So while you pay money, right? So what to tell that one? At payment. Okay, at payment time, you may at payment time. So you may see that kind of message, right? So what is that meaning is if you refresh, the session ID will be changes. Now the transaction will be happens like this. Okay. So your device sending a request, for example, it is a Amazon through Amazon application. Okay, through Amazon application, you are giving your bank details for payment. So then from here it is go to bank, confirm your payment by sending OTP to you, right? So once you are confirmed, then bank will be confirm your payment, final payment. So then it will give the confirmation to your Amazon app, right? Amazon server. Amazon server understand your transaction is successful. Then it will show transaction successful message and back to the remaining process. Okay, you complete a remaining process, then order will be confirmed. Okay, the first one is you have to place an order, then you have to do payment. Once payment is successful, order will be confirmed, right? So all are we are doing in a single app only, but not it is done by one single machine, right? Everything is the payment is again payment gateway, bank is involved. And you have to confirm the payment means using a OTP, you have to tell yes, confirm transmission, then it will give it to this payment gateway. This payment gateway again it will tell your Amazon server, then it will give yes, confirm the order is placed now. Okay, it is not done by one single machine. This is called a distributed system. That is called a distributed system. You know, all these things works based on one single session ID. If in case while your payment is going on, you refresh your page, what happened? Or you close your application, what happened? So that the session maybe amount is done means amount is cut, but it might not give it to you to your application. It is not able to tell application amount is detected, amount is successful. They don't, maybe that part may be missed. Okay, amount is confirmed, but it is not giving information to your Amazon. Or Amazon also received a payment, but order may not be confirmed. Okay, so this kind of issues will occur. That's why it is saying do not refresh or do not press the back button. Another one is guys, internet problems, right? So I'm using one day it has happened to me. I'm using a Wi-Fi internet because it is a very good high speed compared to my 4G, right? So that those days, right? It's what happened. I have to book a ticket, IRCTC. Okay, this is a IRCTC app. I'm from my mobile phone. So I connected to Wi-Fi. So I am accessing this IRCTC. I book a ticket. So I have to doing this money transaction. That time, exactly that time, power cut. So what happened? Because of internet is disconnected, no volume. Why? Because what happened? It is switched to 4G network. So internet is disconnected. The Wi-Fi internet is disconnected. But it is my mobile phone, right? Mobile phone, good is, it is switched to 4G network. Now I'm going through 4G. But session ID changes, transaction is incomplete. Transaction successful, but ticket is not happened actually. Transaction money cut, ticket is not happened. Okay, because session ID changes, so it cannot able to understand the new session, new request kind of stuff. So this is what is happening. Okay, so guys, that is very good things about your session layer. One more we can tell about a story, that is download. For example, you are downloading 100 MB data, you are downloading, right? So nowadays we are getting a fast internet, means 10 Mbps, 20 Mbps, 30 Mbps, minimum 30 Mbps. Also we are getting at least 30 Mbps we are getting nowadays. Okay, but still an example is 100 MB example. First I am taking 90 MB data is downloaded, 10 MB is pending. Now power cut. Array, internet disconnected. Something has happened. 10 MB has to be downloaded, right? So after my internet is back, I try to download. So what to download again? From starting 100 MB, have to start. Okay. Even 90%, 99%, 99.9% is downloaded completed. But if the internet is disturbed, what happened? Session ID gone. Session ID gone. So obviously session is terminated. Once session is terminated, you cannot able to download remaining part. And what we are doing is we use FDM, free download manager, or IDM, internet download manager kind of applications. I'm downloading 100 GB data, 100 GB data, for example. Okay, yeah, I downloaded 100 GB data also. Okay, so 100 GB data I'm downloading. Only 20 GB data is downloaded today. Okay, I have to shut down a computer for the night, so then I shut down my computer. The next day I downloaded remaining things. Again I opened remaining 10. I downloaded another around 40 GB. Around next another 40 GB. Morning I started, 40 GB data is downloaded. Now only 60 GB downloaded. Like 3 to 4 days I downloaded entire 100 GB. How it is possible? 1 minute disconnection is giving a very big problem here. Like a 90% is downloaded, only 10% is not downloaded. Again, I have to download from starting in this scenario. But in this scenario, I am downloading small parts. First time I downloaded that is a very big data, that is 3.4 or 3.5 GB. More than 3 GB data is there. So that time very slow internet speed, 512 kbps. Internet is 512 kbps, 70 kbps download speed. Okay. So total internet is 512 kbps, not 1 Mbps also. Okay. It took almost like a 1 month to download this data. It is nothing but a Windows Vista DVD. Up to Windows XP, it is a CDs only. It is a DVD size, around more than 3.5, 3.6 GB data it is. I have to download from internet. Okay, I use this uTorrent. I download it from uTorrent. So bit by bit it is downloaded. Okay, and that too in office, not in home. So morning we started, Evening we close, morning we start. It will take almost like a 1 month. I got finally DVD. Luckily, it is working. Okay, guys. The session layer is very very important, but very less lines about it. Okay. So this is what session layer it is. So once the connection is established, through that connection only, we are sending a data with a session ID. Once transaction completed means send and receiving is completed, then session ID will be terminated. Okay. Till the time session layer should maintain the session ID. Maybe you understand smart part or okay, session ID, session
Yes, sir.
layer.
Yes, sir.
Guys, this is a transport layer. Transport layer is a very big layer as compared to all other layers. Because of lot of things, you have to speak about a transport layer. So this is okay, but it is why it is. Later I will deal with that one. Just make me disturb my notes. So first one is OSI. What are the OSI layers? What are the protocols? Because application layer, in the part of application layer, you have to tell protocols. Okay, and protocols are also important. Protocols, port numbers are important. The next one is application layer, presentation layer, and session layer. Then transport layer, I will put it in a here. Guys, transport layer provide a end-to-end connectivity. Why it is called end-to-end connectivity? We'll see that one. Transport layer segment the data. Transport layer segment the data. For example, just for our understanding, guys, in reality it won't happen like this. But for our understanding, I'm telling this example. Hello, how are you? Just for our understanding. This is a message I want to send. What is my transport layer will do? Transport layer chop the data into small parts. This process we call it as a segmenting. This process we call it as a segmenting. It's segmenting. Chop the data into small parts. Minimum size is 64K bytes. Maximum size is 1500 bytes size only. Who is this? Yeah, it's a fraud, another fraud. Okay, segmenting, chop data into small pieces. Okay, and here it is 64 to 1500 byte size of each segment part. Okay, and what this transport layer do, it will put a some number. Just for our understanding, I am putting some number. Okay, this is the segment number. Okay, based on its sequence order, total data it chopped into small parts, and each one is given with a certain number, segment number. This is called a numbering and sequencing. Okay, this is useful at error correction. Error correction. How error correction is happen, guys? Okay, error correction. Okay, error detection is different, error correction is different. Transport layer do error correction. Yes, transport layer segment the data. Hello. Tell me. Please tell me what is regarding. I'm busy. Please. Yeah, tell me. Tell me. Already I done FD and RD, both are there. Okay. Yeah, sorry guys. Yeah, when you are sending a data, for example, I send a packet number 1. Okay, receiver received at the receiving side, it received. Packet is received means what is received? Hello is received, and send a second packet. So when receiver received, it will send an acknowledgement. I received a first packet, like that. Okay, I second packet, and then it is received. It will give an acknowledgement. Okay, so I received. So what it will happen? Yeah, it is received how? Third packet is sent, fourth packet is sent, like this. Fourth packet is received. It knows it to send an acknowledgement for a fourth packet. It didn't give any acknowledgement for a third packet. It means you is received. So what is received? Hello, how you received. And where is the third one? Missed. The source will understand, then it will send a third packet. So third is received and we got an acknowledgement, and R is received now. So it is error correction. And because of this numbering and sequencing, it can place these data into order. So what will happen at receiving side? It collect all the packets, all the segments at receiving end. Once it is received all the segments, it arrange it into proper order. Then it will forward to the next step. Okay. So at receiving end. So that is what I am trying to say. It is like this. It is happened. It is transport layer. Chop the data into small pieces called as segmenting, numbering, and sequencing. Okay. It is the numbering and sequence is useful to keep the data into the order, and it is useful to for a error correction. Okay. Okay. So like that. So this is what I already there. Next, someone asked me multiplexing and demultiplexing. Okay, multiplexing and demultiplexing of TCP UDP protocols. TCP UDP protocols. Guys, lot of people just they read a TCP UDP, but of course there is a two explanations are there. Original TCP UDP explanation is there, and second one just for our understanding explanation is also there. Okay. When it is 14. No problem. No, this is a TCP UDP differences. We study everything in our college days and everything we studied. But problem is what it is we don't know. Okay, so no problem. There is two parts are there. Actually, two ways are there. I am going with the normal way, normal general part only. So look at here, guys. TCP rep means transmission control protocol. UDP means user datagram protocol. We have discussed several protocols like HTTP, HTTPS, FTP, SSH, Telnet, RDP, SMTP, POP3, or a DHCP, or DNS, TFTP, NTP, Kerberos, LDAP, like a different type of protocols we discussed. Okay, these protocols, some protocols are TCP type protocols. Some protocols are TCP type protocols. Some protocols are a UDP type protocols. Some protocols are TCP type protocols, some protocols are UDP type protocol. TCP UDP listed. See this is a port number 53. Protocol is DNS protocol, which is TCP and as well as UDP type protocol. DHCP protocol is UDP protocol, HTTP protocol is TCP protocol, and POP3 is TCP protocol. Like this, you can go to different protocols, guys. The protocols can be TCP or UDP type or both. Okay, so we discuss different protocols. In these protocols, some protocols are TCP type, some are UDP type, some are both. Okay, so here is a TCP UDP is a protocol type only. TCP type protocols are acknowledgement based protocols. UDP type protocols do not have any acknowledgement. So that is no acknowledgement based protocol. So acknowledgement is not required. Okay. So these are the protocol list. Okay. And it comes under either TCP or UDP, or it is satisfy both the things. Okay. So look at here, guys. I given some example: HTTP, SMTP, FTP, SNMP. These protocols are TCP type protocols. DHCP, TFTP, both are belongs to UDP protocol. DNS is belongs to TCP as well as UDP. Okay, so these protocols, TCP type protocols are acknowledgement based. UDP type protocols are non-acknowledgement based, means they don't use acknowledgement here. And what is this acknowledgement also I will tell. Originally TCP UDP explanation based on this synchronization kind of things is there, acknowledgement and synchronization part. I'm not going to that explanation, even I don't go to that explanation generally. Look at here, guys. I am sending a message to source to destination. For example, A to B. A is a source machine, B is a destination machine. I send a packet, okay, then destination received and destination will give acknowledgement. Okay, so when A is received acknowledgement from B, it understand B received a packet. B received a packet. A sent a packet, B received a packet, and B is given acknowledgement to A, meaning is B received a packet. A sent a packet, B received or not, we don't know, but A didn't receive an acknowledgement for that packet from B, means B think, so A think B is not received a packet. Okay, it is a acknowledgement based communication. A sent a packet, B received a packet. Okay, B give, the destination will give acknowledgement to the source. Source understand B destination received a packet. If in case source don't receive a acknowledgement from destination, if in case source didn't receive a acknowledgement from destination, or A didn't receive a acknowledgement from B, A thinks or source thinks B didn't receive, destination does not receive a packet. So what it will do, it send the packet again. It send the packet again. So that is a TCP type protocols do. Like HTTP, FTP, these protocols do work like this only. UDP type protocols, user datagram type protocols are no acknowledgement. So what it will do, source send a packet, destination received a packet or not, source don't know. Source don't know whether destination received a packet or not. For example, destination received a packet. Destination won't tell, source don't know. Destination doesn't receive a packet. Destination does not receive a packet. So destination is not telling, source don't know whether destination received a packet. It keeps sending the packets. That's it. It keeps sending the packets. So that's why there are two more lines are there. That is reliable and non-reliable, connection oriented, connectionless. Of course, some people said UDP is a faster, TCP is a slower compared to UDP. Because of TCP is waiting for a acknowledgements. Okay, if once acknowledgement confirmed, then packets will be delivered. If acknowledgement is not confirmed, so again it will keep sending the packets. So it is slow down the communication. But it is UDP, it does not wait for any acknowledgement. It will keep sending the packets. Okay, why it is reliable? Why TCP protocols, TCP type protocols are reliable? Because of source no, destination is received a packet. That's why it is reliable. And TCP protocols are connection oriented. You know, some people will give bad example. That is a wide and wireless example. If you are using a Wi-Fi kind of network, that is a UDP. If you are using wired, that is a TCP. That is wrong, guys. Completely wrong. Even a big professor came and tell that one also it is wrong. Okay. So a lot of myths are there. Still, I don't know whether college is teaching same thing or not. So I don't know about it. But still, what I'm trying to say is this is wrong. Okay. Point is again. Point is why it is called connection oriented and connectionless. Guys, connection oriented means, for example, someone is speaking and other person giving some kind of acknowledging, means yes sir I understand, are giving some questions like if you there is a two-way communication is there, means sending as well as the receiving. So source send, destination received and given acknowledgement. So it is a two-way communication is there. So that's why it is a connection oriented. Connectionless, keep sending. We don't mind whether destination received or not. Okay, we don't know whether destination is not received or not. It's like a off duplex communication or a simplex communication type. So no two-way communication it is. No acknowledgement from the destination. Source don't know destination is received or not. So it is a connectionless. Okay, connectionless, connection oriented. It is only names. So in the olden days, when to explain about a TCP UDP, they use these words for connection oriented, connectionless. It nothing to do with wired or wireless connectivity, guys. Connection oriented means source no, destination is able to receive based on the destination is sending acknowledgement to the source. So two-way connectivity is there. That's it is connection oriented. Whereas the UDP type protocols will send up data but not getting any acknowledgement from the destination. That's it is a connectionless. Source don't know whether this destination received a packet or not. Okay. Already I told no, there is another point is there, that is a slow, fast kind of stuff. Of course, we don't use any acknowledgement. No need to wait for acknowledgement. Here we are using acknowledgement. So every packet after sending, so we have to wait for the source has to wait for acknowledgement to confirm packet is delivered. Guys, understand TCP UDP, connection oriented, connectionless, reliable and non-reliable.
Yes, sir.
Yes, sir.
Okay. Flow control and windowing. What happened? Okay. Next one is flow control and windowing type. Both are two different techniques. Flow control is a one technique. Windowing is also one technique. But commonly I am telling guys, this is my source. For example, I am sending. Here is my destination. I have to receive from here. For example, I am using 1 Gbps speed, but here it is 100 Mbps Ethernet speed. So I can send data very faster, right? But destination cannot catch all the packets at a time. Like I can send 10 packets at a time, but destination can reach only 5 packets at this particular instant. I can able to send 10 packets at a time, but destination can receive 5 packets at a time. Okay, collecting the data. Okay, so then what technique it is using? That's a flow control technique. So estimate how many packets destination can able to receive. So that many packets only will send it at a time. So one by one packet is will take longer time. That's why we'll send all the packets at a time. All the packet means 10 packets, 20 packets, 30 packets at a time we are sending. So but destination cannot receive all the packets, means what are all the packets sent by source cannot be received by destination. So some packets will be dropped. So source understand that situation and it will change the flow control. So it will keep sending only 5 or 6 packets at a time only. This is called a fault control. Same goes for windowing also, but windowing will tell like I am sending 5 packets. First only it is tell I am sending 5 packets. So it will wait to collect all the 5 packets. All 5 packets are received and it will give acknowledgement for 5 packets. It will send I am sending 10 packets. So destination is wait for all 10 packets to collect. 10 packets are received, it will give acknowledgement. Okay, so like this it works. Means source and destination will know the how many packets at a time they have to receive. Okay, guys, whatever the data, so each layer having a data. Application layer data is there. Okay, that data is called the layer data, we call it as a PDU, packet data unit. Application layer packet data is application layer, PDU is nothing but data. Okay, just the data. It's not alter data, it is. Presentation layer. So presentation layer out of means this application layer data is go to presentation layer. It is encrypted, it is encoded, it is compressed. So after that data, what are the data outcome of data means that is also a PDU. That PDU is also called as data only. Packet data unit. The data in the layer, the layered, each layer, what are the data in the each layer, the outcome of the layer is PDU, packet data unit. And session layer adds a session ID to your PDU. Then this is the PDU. This PDU is sent now, it is to transport layer, right? So application layer PDU sent to presentation, presentation layer PDU sent to session layer PDU sent to transport layer. This transport layer, the PDU means this packet data unit, the received from session layer will be segmented, numbered, sequence, and multiplexing of TCP UDP protocols. Multiplexing means so they'll maintain a one box like this is a TCP box, this is UDP box. While you are communicating, what protocols you are using, so the protocol is TCP type, put in a TCP type box. The protocol is UDP type, put it in a UDP box. Okay, so like this is a multiplexing, windowing, window numbers. Okay, so all this information stored in this PDU. Okay, so what transport layer will do? The receiver's PDU, segment, numbering, sequencing. Okay, after that one, what happened? This TCP UDP multiplexing and windowing. So then finally, there is a TCP header added to this PDU. So then this is called a segment. This is called a segment. What is packet data unit, guys? Data in the layer. Data in the layer or data from the layer is called a PDU. Any layer, it is a PDU only. Okay? Any layer, it is a PDU. But application layer, presentation layer, session layer, the PDU do not have any names. It is only data. But in a transport layer, the PDU is added with the TCP header, which is information in the TCP address about a segmenting, numbering, and protocols like a TCP, UDP type protocols. Everything is added here to our PDU. That is called our PDU. We call it as a segment. This segment, our PDU is a segment now from transport layer. It is sent to the network layer. To the network layer. Okay. So what is a segment, guys? What is segment? So the transport layer PDU, the PDU packet data unit name from transport layer means TCP header plus PDU is called a segment. Okay, this segment will be sent to this network layer. In network layer, actually dealing with the routed protocols and routing protocols. Routed protocols means logical addressing, nothing but a IP address. Of course, different type of logical addressing are there, like IP addresses, IPXS, PX kind of stuff, addressing schemes also there. But I'm talking in IP address manner only. IPv4, IPv6, these are IP addresses. So network layer is dealing with the routed protocols and routing protocols. What is routing protocols? Routing protocols will create a routing tables. Using the routing tables, we can reach the destination, right? Routers, routing tables are created by routing protocols, dynamic routing protocols. Using these routing protocols, we can reach the destinations, right? Google.com, Facebook.com, YouTube.com. We are able to reach based on this routers routing tables only. Okay, so depends upon the way of your communication. So routing information and routed information means your logical IP addresses, logical addressing, as well as the routing protocols information is also added here. So there is a network header. We'll be going to add your segment. The network header is added to your segment called a packet. Now our packet data unit is packet. Our packet data unit is packet from network layer. Outcome of network layer is packet. PDU from network layer is packet. So network header means source IP and destination IP address. So your segment is added with a network header. So network header plus segment, meaning is source IP and destination IP address is added to your segment. So the total we call it as a packet. What is packet contain? Source IP, destination IP, of course, routing information also added. It is not given there, but plainly it is source IP, destination IP. So this packet is sent to the data link layer, guys. Only transport layer is very bigger. Remaining also very important. Bigger size is transport layer size is bigger, lot of responsibilities. Data link layer. So this packet is sent to the data link layer. In data link layer, so what will happen? Data link layer having a two sublayers. One is LLC, logical link control. Another one is a MAC layer. This logical link control dealing with the WAN protocols. You want to connect in the WAN. we have to connect, you want to connect it to the WAN network, you have to use WAN protocols. Okay, guys, normally LAN and WAN, we are differentiate with the geographical size, right? Because of there is a LAN, CAN, MAN, WAN is there, so we put a geographical size in it. But originally, WAN connectivity can be also smaller. Within the building also we can create a WAN connectivity. Point is, what protocols, what administrative points are there? So based on that, we have to decide it is a LAN or WAN. Okay. So again, data link layer having two layers, two sub layers. One is LLC, logical link control. Another one is MAC layer. Okay. So what is this LLC dealing with the WAN protocols, PPP, SDLC, frame relay, MPLS, kind of WAN connectivity is decided at LLC. Next one is our network layer. It is like a data link layer. So MAC layer is there. Second one is MAC layer, media access control. You know MAC address already. It is a 48-bit or a 12 hexadecimal. It is also called as a physical address. This MAC address will be added as a data header to your packet, and data tail will be also added to your packet. The data tail is CRC, cyclic redundancy check. Guys, source MAC address, destination MAC address is added to your packet plus CRC. What is CRC? Cyclic redundancy check. CRC is an algorithm used to check errors, data errors. For example, I received a packet, sending and receiving, right? So there is two things are there, sending and receiving. So I received a packet. So this is a physical layer, this is a data link layer, this is physical layer, this is a data link layer. I received a packet and physical layer given the packet, that means the to our data link layer. In data link layer there is a CRC. This CRC will check the data is any errors are there in the data. While transmitting data from one place to another place, data can be corrupted, right? So this CRC algorithm use it to check for a data errors. So it will do error correction kind of stuff. So remember guys, transport layer error correction, data link layer error checking. Okay, so do not confuse. Data link layer will do error checking using CRC. Transport layer will do error correction using this acknowledgement based. Okay, using acknowledgement kind of stuff. Means we'll send a packet if destination not received a packet, so we'll send a packet again. That is error correction there. Here it is error checking. CRC, cyclic redundancy check, use it to check for errors. Okay, so this source MAC address, destination MAC address, the packet from network layer plus CRC, the total one we call the total PDU we call it as a frame. This frame is sent to the physical layer. Okay, frame is sent to the physical layer. The frame is converted into bit stream. Frame is converted into bit stream at physical layer. Okay, frame is converted into bit stream at physical layer. Okay, so what is the bit stream? It's like a binary code type 0101 kind of stuff. But this bit stream based on your physical device. If you are using a Ethernet, for example, you are using a Ethernet and you are connecting with the UTP, STP cables RJ45 connector, right? So what signal it is? Electrical signal. If you are using a Wi-Fi kind of stuff, your Wi-Fi router, mobile phone, laptops, Wi-Fi connectors are there. So while you are sending and receiving through your Wi-Fi means radio signal it is. For example, you have a server or a storage, SAN kind of storage devices are there, or you have a server or a big routers are there, or maybe you are connecting to internet. So that is a fiber channel connectivity. So the bit stream is converted into light wave signal here. Guys, the physical layer is provide a physical connectivity based on the physical NICs, based on the physical connectivity or physical NICs or physical adapters. The signal, the bit stream is converted into that type of signal it is, that according to that type of signal it is, like electrical signal, a radio signal, or a light wave signal. Okay, guys, up to here, okay, understand? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and a physical layer. Yeah, don't worry, I will but no one is telling anything. Guys, do you understand this point or need any other?
No, sir, we understand. We understood.
Yes, sir.
Understood.
Okay, good. Very simple way, guys. I want to communicate from PCA to PCB. PCA is a source and destination in a first time, but later it will be changed. Application layer. What I want to do it? I want to do ping from PCA to PCB. Ping. Where do you do ping? Command is command prompt. Ping command we use on a command prompt only. We can't do in browser, right? ICMP protocol. Ping use ICMP protocol. See it is. I want to open a website in a web browser with HTTP or HTTPS protocol. So application layer is dealing with the protocols and the application. Okay, either client side or server side application, right? So that is a application layer. Understand both protocols and application part. Presentation layer, whatever it is, whatever your command or whatever your protocol, whatever your application you are using, the data will be encoded, compressed, encrypted at presentation layer. So to that data, the session layer will add a session. So new session is created now. The data is sent to the transport layer. At the transport layer, data will be segmenting, numbering, sequencing, flow control or windowing, TCP, UDP, multiplexing happens at transport layer. The total, the TCP header will be added to your PDU. Then we got a segment. This segment is sent to the network layer. The network layer adds source IP and destination IP to this segment. Source IP means PCA IP address, PCB IP address. Guys, I am going to write something here. So, okay. PCA currently. While sending a packet from network layer, I am writing source IP. What is source IP? Yes IP. APC IP address. Destination IP address. What is destination IP address? VIP. Next one. So what is, we got it from network layer packet. The packet is sent to the data link layer. Data link layer add a source MAC address and destination MAC address and CRC value to our packet. Then totally we are getting a frame. So what is happened? Next one is, what is the source MAC address? As for us, it is yes MAC address. A is a sending. So we know ACE MAC address. So other side it is receiving. So destination MAC address, right? You don't know destination MAC. If you know the destination MAC address, it is a BS MAC address. If you know it. If you don't know, if PCA don't know this MAC address, it use MAC broadcast address. You know what it is? FF. So how many Fs completed? 6 Fs. We needed 12 Fs. MAC broadcaster. Okay, if you don't know the destination IP, we use broadcasting address. I know the destination IP address, but I don't know PCA, I don't know destination MAC address. So if you don't know destination MAC address, so what it use? It use as a destination MAC address. As a destination MAC address, it use MAC broadcast address. So this is from A. Okay, source MAC address, destination MAC address, and packet plus CRC, cyclic redundancy check. That's a CRC value from your data only. It is created. Now it is a frame. The frame sent to the physical layer. Physical layer convert this frame to bit stream to electrical. For example, I'm using wired connection electrical signal, or wireless means radio signal, or a fiber optical means it is a light wave signal. So whatever it is, we are sending. Who is receiving? PCB. And which layer it is receiving? At which layer it is receiving? Physical layer. Guys, I said no, while sending, application layer is starting. While receiving, physical layer is starting. Physical layer received a data. So it converts this electrical signal into bit stream to frame. Now we got a frame. Physical layer finally got a frame, means physical layer received a electrical signal converted into bit stream to frame. Guys, understand up to here this point?
Yes, sir.
Yes, sir.
Yes, sir.
At B, at PCB. Okay, so this frame is sent to the data link layer. So what is the frame contains? Source IP. Sorry. The frame contains source MAC address, destination MAC address, and CRC. So what I'm receiving? I received a yes MAC address and B's MAC address as either MAC broadcasting or a B's MAC address also. Depends upon the time of communication. Okay. Already one communication is done, means once transaction completed. So next time no problem. Okay. How it is no problem? I will tell. Okay. Here. That's why I'm writing this point. At PCB, it received a packet from ACE. Okay. So it store ACE MAC address. So it will put a MAC address aside. It received a ACE MAC address. Next one is network layer. So what it will do, guys, again data link layer, check the source MAC address, means received a MAC address, A's MAC address, B's MAC address. It check with the B's MAC address, same or not. Okay. Next one is CRC. Using this CRC, it verify the packet. So it's verify your data. Data is good or data is corrupted. If data is corrupted, discard the packet. Data is good. Then extract the packet and give it to network layer. What is the network layer contains? Network layer, open this packet, check the source IP, destination IP, and extract the segment. Yeah, tell me.
The source IP and the destination IP.
Didn't get it. Okay. So we data link layer. So finally extract the packet, send to the network layer. What packet contains? Source IP address, destination IP address means A's IP, B's IP, and segment. What system will do? It verify is the packet is from for me or not. To address should be for my address, right? I have to receive a packet means the to address must be my address. So it check the destination IP is B's IP or not. If it is same, then it accept the packet, otherwise discard the packet. And also it will do, it stores A's IP like this. So B received A's MAC address and as well as A's IP address also. Okay. Now it extract the segment from it. Segment is came, give it to transport layer. This transport layer collect all the segments. Not one segment, guys. It collect all the segments, put it in an order, number and sequencing using numbering sequencing. It put it into the order. If any particular segment is missing, so that packet will be received later anyway. So it is arranged it properly. It do error correction. Okay. It check the TCP and UDP multiplexing and get the TCP type protocols or UDP type protocols, what protocols you are using, what segments are there, arrange the segments as a one single packet. So it will combine all the segments. It combines all the segments, then it will give that PDU to session ID. Session layer, sorry, give it to session layer. Session layer verify the session ID. It stores the session ID aside. Okay. Yes, this is the session ID. Like that, it will understand the session ID. And it give that remaining data to presentation layer. Again, presentation layer decode the data. Presentation layer encoding, decoding. Right. So while you are sending, you will encode. While you are receiving, you decode the data. You decrypt the data because you are encrypted already. Now it is decrypted. You decompress the data because while you are sending, compressed. While you are receiving, you decompress the data. Now data is normal. So decoded data it is. Second one is uncompressed, decompressed, decrypted data is given to your application layer. Application layer understand what kind of protocol, what kind of request it is, whether you have to give reply or you have to give what kind of reply. Okay, so that is application layer will do. Again, for example, mail communication. You send a mail, other side received a mail, right? SMTP protocol or POP3 IMAP protocols we are using, right? So while you are sending, you send with a client application. While you are receiving means at a destination, it is a server, right? Server application, mail server application like a Microsoft Exchange application. Okay, so this is the application layer part, right? Applications, protocols, understanding of protocols. So based on that, it will give reply. Again, chain will be same, guys. Application layer will giving reply to the from PCB to PCA. Giving there is a reply from PCB to PCA. So what will happen? Again, application layer, presentation layer, encoding, compression, and encrypting. Session ID will be added here. Again, segmenting data, numbering, sequencing, TCP, UDP, multiplexing, windowing, flow control kind of stuff. Now, at network layer, things will change. Source IP is a BPC IP. Destination IP is a APC IP. And DataLink layer. So the totally added to segment, we got a packet. Packet go to DataLink layer. Source MAC address is BPC MAC address. Destination MAC address is APC MAC address. And CRC will be value will be added to your packet. Okay, then frame is created. The frame sent to the physical layer. The frame convert into bitstream into electrical signal, and send the finally at destination physical layer will be received. Okay, again physical to data link, network, transport, session, presentation, and application. PCA finally received the data. Guys, while I'm telling at this point, 2 points at PCB, while receiving a packet, so I taken a ACE MAC address and I have taken a ACE IP address. So at PCB, what will happen? It creates ARP table. Okay, it creates a ARP table at PCB. It create a ARP table, which is nothing but maps IP address to MAC address kind of stuff. Okay, so like this, ACE IP address, ACE MAC address. ACE IP address, ACE MAC address. So this is the ARP table part. So IP address, MAC address, ACE IP address, ACE MAC address. It will create a ARP table. Using this ARP table, while it is communicating to ACE PC from B to A, while it is communicating, what it will do? Destination MAC address, no confusion. We have a destination MAC address. Destination IP address, you know the destination IP address, so then automatically you know the destination MAC address. How? Because of ARP table. I'll show you the ARP table, guys. ARP command is also there. Go to command prompt, type ARP space -A. So this is the ARP table. These are the different devices in my network. Okay, the devices are a computer or a devices, their IP address, which is their MAC address. This is the IP address of the remote device and their MAC address. IP address of a device, their MAC address. This is my IP address. This is my current IP address. This is other devices connected in the network. So while I'm sending and receiving a packet, while I'm receiving a packet, the packet contains the MAC address and that device IP address. So what my machine is doing, it take the MAC address and take the IP address, put it into a table. Okay, so these are all learned in a dynamically. These are learned in a dynamic manner. Automatically, it will learn MAC address and IP address of the devices while it is receiving a packet from there. So you put a ARP, that's just a question mark. Yeah, no, it is not question mark. Help. Okay, these are two things. If you want to add a ARP yourself, this is used to, this is a command ARP space -S. You can create your own ARP table statically. Usually if you go to any high secure places like a more security required in an internal network, also security is required, that places ARP static entries they use it. In generally we don't normal network communication we don't use it. ARP A is enough, but in the static entry of ARP is this one. Means IP to MAC address we are binding If IP and MAC is matching, accept the packet. IP address, MAC address, both are matching. While you are receiving a packet, IP address of packet and MAC address is matching, then only accept the packet. That kind of stuff is there. Guys, while you are communicating, means while you are receiving a packet, the packet contains source IP address and source MAC address while you are receiving a packet. So your system take this MAC address and IP address, put it into a table that is called a ARP table. What is ARP? Address resolution protocol. Okay, it maps IP address to MAC address, which is very useful while you are communicating in the network. While you are sending a packets, no confusion, so you will get it. Okay, this is the point, ARP point also I told. Okay, address resolution protocol. Guys, understand anything?
Yes, sir.
Yes, sir.
Yes, sir.
So OSLA is a big story, but compulsory. So this is in the table form, that is a column, that's why short ascending, what is this? Insert a one row below, pin header this row. I don't know what it is. Now we can understand now. This is good. Okay, you can reduce this size. If you reduce the size, it is give better. So it is now, it is good. I didn't read this one, guys. I don't know what is this table contains. Just I given, okay, like that. So this is about this one. So take a small break, guys. Only 5 minutes. So we'll complete first this topology part. Again, it will take 20-30 minutes. So we'll complete this topology part first of all. So tomorrow I will tell completely IP address. So we are taking lot of time on networking only, but tomorrow is Thursday, right? So we'll go through this part. Okay. Now just take a break, 5 minutes.